let's talk about the unit circle, radians, and degrees in this video. So first of all, so when you think of 360 degrees, right, that's a full circle. The conversion for that will equal 2 pi radians. Now, if you wanted to know how to convert from 360 degrees to radians, think of it this way: 360 times pi over 180. 180 goes into 362 times, so the answer is 2 pi. Use this as a sort of reminder. If you remember that, then you can convert from degrees to radians. And if you want to convert from radians to degrees, you do the same. You do a similar thing, right? You have 2 pi, right? And then 180 over pi. The pi's will cancel and you're left with 360 degrees. That is how we can find our degrees to radians and radians to degrees. It's a good skill to have, and make sure, again, when you're doing work that you convert, that you change your calculator from degrees to radians or radians to degrees, depending on the situation you're working with. But this is one important piece of just mathematics, converting from radians to degrees back and forth. So now we're going to tie it to the unit circle. From the unit circle, we can get different values for cosine and tangent and sine. Remember that we've talked about tan theta is equal to sine theta over cosine theta. And you'll see some of that with the unit circle. So let's look at a few values of the unit circle. Let's start right here. So right here we have 0. We have 0. We have 1, 0 as the coordinates on this unit circle. So then we have 30 degrees, we have 60 degrees, 45 degrees, and then we'll have 45 degrees, and then we have 60 degrees, and then we have 90 degrees over here, right? We have 180 degrees over here, we have 270 degrees over here, and then technically comes back around to 360. So you come around and back to 360, right? So that is something to keep in mind. If you go around the circle, you come back to 360 degrees. So when we're looking at the radians, by the way, so this is 30 degrees, but if you want to convert this now, you could say 30 times pi over 180, right? So that will end up being pi over 6. Okay, so that's pi over 6. You can calculate this one. You would end up getting pi over 4. This is pi over 3. This is pi over 4. This is pi over 2. I will change that here to pi over 2. So that's pi over 2. And then you move across. Again, if you do the math, you'll get 2 pi over 3, which corresponds to 120 degrees. And then we have 135 degrees, 150 degrees. And these correspond to 3 pi over 4 and 5 pi over 6. Right? Those are the radian values. Over here, 180 degrees is a pi. We continue on to 7 pi over 6, and we have 5 pi over 4 and 4 pi over 3. And now we're going to write the degree values. We have, in this case, 210 degrees. We have 225 degrees and 240 degrees. We continue on here. We have 270, which is the same thing as 3 pi over 2. We continue now to 300. So this is going to be 300. This is going to be 315. This is going to be 330. So 330. And then we have 360, as we said. The radians would be, this would be 11 pi over 6. And then 7 pi over 4. And 5 pi over 3. So now we've described the different angle dimensions. So then we can look at what is sine 45 and what is cosine 45. Let's look at this one over here. And this one is actually not bad to derive. And once you derive that, you would notice that there's a relationship of that on the other side. There's a relationship between this one and that one. They have a relationship. Okay, so a lot of these all have some sort of relationships that you can keep in mind. Before I mention these relationships, I want to remind you that SOHCAHTOA, sine is opposite of a hypotenuse. So let's quickly do their relationships and then we'll continue on. So basically we have, if we look at this, the relationships here, there's a lot going on, but let's look at it one by one, starting with the 45. You see this 45 here with pi over 4. There's going to be a relationship to this over here. And let's look at that here. If I say what is sine 45 degrees, using that special triangle we talked about, you remember you had basically 1 and 1 and square root of 2. And so sine 45 degrees would be 1 over square root of 2, which becomes square root of 2 over, well, actually, you have to rationalize the denominator and becomes square root of 2 over 2. So sine 45 degrees and cosine 45 degrees are actually square root of 2 over 2. If you do the work, you get the same answer, square root of 2 over 2. So this one over here also is square root of 2 over 2 and square root of 2 over 2. But the signs are going to change. Now, if you have a unit circle, please feel free to pull it out and you can see all the other values. I just wanted to show you one relationship here quickly. But you would notice that square root of 2 over 2 on this quadrant, though, there's a formula that we use, or there's an acronym. We have ACTS. So ACTS, ACTS, okay? ACTS, meaning that in this quadrant, everything is positive. In this quadrant, cosine is positive. In this quadrant, tangent is positive. In this quadrant, sine is positive. Now, there's a lot going on with the unit circle. This is more like supplemental knowledge for the, this is not focused on the ACT especially necessarily. This is more just for you to be aware of. This will help you in pre-calc and could help in on the ACT, but this is extra, I would call it. So we know that the cosine is positive there. So if I fill in all the numbers, for simplicity, here's what I'm going to do. I'm going to try and reproduce a quick circle here. Oh, actually, if I just do it over here, we've done this first one with the 45. 30, if we did the work, we would find that it is square root of 3 over 2, comma, 1/2. Okay? Now, again, that will correspond to this over there. That will correspond, and the signs will actually be negative square root of 3 over 2 and negative 1/2. And then, so we've looked at this one. That's think of the cosine of 30 as square root of 3 over 2 and the sine as 1/2. Think of the cosine of 45 as square root of 2 over 2 and the sine as square root of 2 over 2. And then here, think of the cosine as 1/2, the cosine of 60 degrees, and the sine as square root of 3 over 2. Notice that it's the opposite of this. And then for 90 degrees, we just have 0 and 1 as we did earlier. So when you think of cosine 90 and sine 90, right? Remember the graph of that showed you some of that information. When we graphed sine, it would look like that. When we graph cosine, it looked more like that. They have their zeros at different spots, right? So cosine 90 is actually 0, while sine 90 is actually 1, because that's 1 here, which matches to pi over 2. So that's pi over 2 on our graph. That's pi, and then this was 2 pi. So we can discuss this more later. Just wanted to give you a sketch of the unit circle, get you thinking about some of the values. These values that we derived over here repeat themselves around the circle. The only difference is that the signs change depending on each quadrant. They're all positive in the first quadrant, and then only the cosine is positive in this quadrant, the fourth quadrant, and so on and so forth. Let me know if we're counting at 1, 2, 3, and 4. And so let me know if you have any questions. This was just a supplemental material. Have a great day.